Welcome back to another deep dive. We're taking your source material, all that information overload, and turning it into aha moments.
Like that.
Today, it's all about Kafka Sink connectors.
Oh, cool.
Those clever components that bridge your Kafka topics to other systems. You're already familiar with Kafka's real-time data streaming, but think of these connectors as the delivery trucks that get that data where it needs to go.
That's a great analogy. And we've got two fascinating use cases from your sources. First up, we're diving into the world of real-time action. Imagine an online order triggering instant inventory updates or a sensor reading setting off an alert. That's the power of the HTTP Sink connector.
Sounds incredibly powerful.
Yeah.
But also a bit complex to set up. Is it really that straightforward?
It can be, especially with the practical guide you've provided. We'll unpack how this connector takes data from Kafka and pushes it to a web API. It's all about making your systems more responsive and dynamic.
Okay, I'm intrigued. Let's talk about the second use case. What about long-term storage and big data analysis? I'm assuming that's where Amazon S3 comes in.
You got it. The Amazon S3 Sink connector. It lets you seamlessly archive data from Kafka topics into those S3 buckets. Think durable, scalable, and cost-effective storage for all those customer trends, machine learning algorithms, and historical data analysis.
So whether you want to trigger real-time actions or unlock insights from your data, Kafka Sink connectors seem essential. But I have to admit, the world of web APIs and S3 buckets can feel a bit daunting at first.
It can be.
Let's start by demystifying the HTTP Sink connector. What makes it so versatile, and how does it actually work?
Well, the magic is in its ability to handle different types of HTTP requests. It can POST new data, PADCH existing data, or even PUT to replace data entirely. It's like having a multi-tool for data delivery.
That's pretty cool. So it's not just a one-size-fits-all approach to sending data.
Right.
What about efficiency? I imagine sending individual records could create a lot of back and forth.
Yeah, you're right. And that's where batching comes in. The connector can bundle multiple records into a single request, saving bandwidth and processing power. Think of it as sending a whole truckload of goods instead of individual packages.
Ah, that makes a lot of sense. It streamlines the whole process. But what about security? How does the connector ensure data stays safe in transit to a web API?
Security is paramount, especially with sensitive information. Like basic authentication and OAuth 2 to control access. And it supports SSL encryption to protect data in transit. It's like having a secure tunnel for your data.
So we've got authentication to verify who is sending the data and encryption to scramble it up while it's traveling.
Exactly.
But let's face it, things go wrong sometimes. What happens if a record fails to reach its destination? Does it just disappear?
Not at all. The connector utilizes a dead letter queue, or DLQ. Any records that encounter errors, like a network issue or an unavailable API, are redirected to this queue for further investigation. You can then retry sending them or analyze why they failed in the first place.
Okay. It's like having a safety net for your data.
Right.
Ensuring nothing gets lost.
Exactly.
That's reassuring. But I'm still struggling to picture how I would actually use this. Can you give me an example of how this connector could make a system more responsive?
Absolutely. Let's say you have an e-commerce platform and you want to send instant notifications to customers about their order status. As soon as an order is placed, the HTTP Sink connector can deliver that event data to your notification service, triggering an email or SMS update in real time.
Okay, that's a great example. Instead of customers constantly checking their order status, they get instant updates, making the whole experience so much more seamless.
Exactly. Or think about a system that monitors sensor data for critical events. Let's say a temperature sensor detects an anomaly. The connector can relay that information to an alert system, allowing for immediate action. Prevent potential problems before they escalate.
That's a fantastic use case for time-sensitive situations. The connector becomes this crucial link between data and action, ensuring a really swift response.
Okay, I'm starting to grasp the power and versatility of the HTTP Sink connector. But before we jump ahead, let's talk about setting up the receiving end, the HTTP endpoint itself. What are the essential components involved in getting that ready?
You can think of the HTTP endpoint as the designated drop-off point for your data. First, you'll need a web server to handle those incoming requests.
Yeah.
You could use traditional options like Apache or Nginx, or leverage a cloud service like AWS API Gateway for a more managed approach.
So it's like setting up the receiving dock where the data shipments will be delivered.
Precisely.
What happens once the data arrives at this dock? You need to define an accessible endpoint URL. This is essentially the address where the connector will send the data.
So if the web server is the dock, the endpoint URL is the specific door where those data packages are supposed to be delivered.
Precisely. And behind the door, you need to implement logic to handle the incoming data. This could involve parsing the data, storing it in a database, or triggering further actions based on the content of the data.
So the endpoint doesn't just passively receive data, it actively processes it and potentially triggers other actions based on what's received.
Exactly. And remember, the API you set up can support different HTTP methods like POST, PCH, or PUT, depending on how you want to handle that incoming data.
Got it. So if you're creating new data, you might use POST.
Right.
But if you're updating an existing record, PTCH would be more appropriate. But what about security? We don't want just any random data package showing up at our doorstep.
You're absolutely right. Just like we talked about securing data in transit, you need to secure the endpoint itself. Using HTTPS to encrypt data is crucial, and you'll likely want to implement authentication mechanisms like API keys or OAuth tokens.
So it's like having a security guard at the door, checking credentials before letting any data through.
Exactly.
That makes sense. Is there anything else our listeners should consider when setting up this endpoint?
Thorough testing is always a good idea. Tools like Postman allow you to send test requests to your API, making sure everything is functioning correctly before you connect it to your Kafka pipeline.
That's a great tip. So to recap, setting up an HTTP endpoint involves choosing a web server, defining the endpoint URL, implementing logic to handle the data, and of course, making it all secure.
Precisely. Once you have this foundation in place, you're well on your way to harnessing the power of real-time data integration with Kafka.
This is fascinating stuff, but let's not forget about the other side of the coin. Long-term storage and big data dreams. I'm ready to dive into the world of Amazon S3 and the Kafka connector that makes it all possible.
Let's do it. We'll explore how to seamlessly move data from Kafka to S3, unlocking a world of possibilities for long-term storage, analysis, and more.
We just explored the HTTP Sink Connector and how it fuels all that real-time action. Now let's switch gears to the world of long-term storage. I'm ready to jump into Amazon S3.
Okay, yeah.
How does the Kafka connector make that integration seamless?
Think of Amazon S3 as this massive secure data warehouse, and the Kafka Amazon S3 Sink Connector as the efficient logistics system that get your data there. It's all about taking those continuous data streams from Kafka and channeling them into S3 buckets.
So durable, scalable, and cost-effective storage. It sounds like the perfect setup when you need to keep that data for the long haul, whether it's for analysis, backups, or just having a historical record. But I'm curious about the why behind choosing S3 specifically. What are the advantages compared to other storage options out there?
Well, durability is a big one. S3 is really designed for resilience. You can be confident your data is safe and sound. And then there's scalability. S3 can handle massive data sets without breaking a sweat. And let's not forget cost effectiveness, especially for data you might not access all the time, but still need to keep around. It's often way more economical than keeping everything in a fast, always-on database.
Those are some pretty compelling advantages, especially for organizations dealing with just the sheer volume of data that we see these days. But what about the connector itself? What makes it stand out compared to, say, just writing custom scripts to move data to S3?
Guarantees. This connector ensures exactly once delivery. That means each record from Kafka is delivered to S3 just once. No duplicates, no missing data points. Critical for maintaining data integrity, especially if you're planning on doing any sort of analysis down the line.
Oh, that's a huge relief. I can imagine the headaches of trying to manually deduplicate data or track down missing records. Sounds like this connector really takes care of all that behind the scenes.
Exactly. It uses some pretty sophisticated mechanisms to manage that data transfer and handle any potential interruptions, errors, all that to ensure accuracy. So you can focus on using the data, not worrying about whether it's all there and consistent. But what good is a data warehouse if it's a total jumbled mess, right?
Right, exactly.
How does the connector help organize all this information once it gets to S3?
You took the words right out of my mouth. Thinking about these huge amounts of data can be overwhelming. So what are the organizational tools within the connector?
Partitioning. Think of it as creating a well-structured filing system within your S3 buckets. The connector lets you partition by topic, by specific fields within your data, or even by time. It's like folders and subfolders, keeping everything tidy and easily searchable.
So if I'm looking for data from a specific Kafka topic, I know exactly where to find it in its own little S3 partition. That's a great way to manage that potential chaos. But what about different data formats? Does the connector force you to structure your data in a specific way before sending it to S3?
Not at all. The Amazon S3 Sink Connector is super flexible. It supports popular formats like Avro, JSON, Parquet, even raw bytes. You choose the format that best suits your needs, your analytical tools, all of that.
Fantastic. Gives you the freedom to pick the format that makes sense for how you'll be using the data later on. Parquet for efficient querying, JSON for human-readable data, Avro for kind of a nice balance between the two.
Exactly.
But what happens if the data coming from Kafka doesn't quite match what's expected in S3? Like a schema mismatch, for example.
Good question.
Could that cause problems?
It could. But luckily, the connector has a safety net for that. The dead letter queue, specifically for schema compatibility issues. Any record that doesn't adhere to that expected schema gets diverted to this queue, prevents data corruption, and gives you a chance to investigate and fix the problem.
It seems like these dead letter queues are a recurring theme with Kafka connectors. And for good reason.
They are, yeah.
They give you that extra layer of protection, ensure data integrity, prevent any loss. It's reassuring to know those safeguards are in place.
They are absolutely crucial. Now, before we jump into setting up those S3 buckets, let's step back and consider some broader best practices for configuring both the HTTP and the S3 connectors.
All right.
Getting these details right can make a world of difference.
That sounds like the perfect transition to the final part of our deep dive.
It is.
We'll be back in a flash to talk about those essential configuration tips and wrap up our exploration of Kafka Sink Connectors. We're back and ready to wrap up our deep dive into Kafka Sink Connectors. We've covered a lot of ground, from real-time data with HTTP to that long-term storage in Amazon S3. Now let's talk about fine-tuning these connectors for maximum performance. Expert, where do we even start? What are some of those key configuration choices?
Well, whether you're working with HTTP or S3, there are a few crucial settings that can really make or break your data pipeline. Let's kick things off with batching for that HTTP Sink connector. Remember, we talked about bundling multiple records into a single request for better efficiency, but there's a bit of an art to finding the right batch size.
So it's not just about cranking the batch size up to the max. There
Right.
are some trade-offs to think about.
Exactly. Larger batches do mean fewer requests, which is generally good for overhead on the network and processing on the receiving end. But if you need that real-time delivery, those bigger batches can introduce some latency. You're waiting for that batch to fill up before sending it off.
Okay. Smaller, more frequent batches might be better if responsiveness is super important.
So it's about finding that sweet spot.
Right.
Speed versus efficiency.
Exactly.
What about those inevitable hiccups, like network glitches or temporary API outages, things like that? How do we make sure we're not losing data when those interruptions happen?
Retry logic is your friend here. You can actually configure the connector to retry sending those failed records automatically a certain number of times before it just gives up. Helps overcome those transient issues and make sure your data ultimately gets to where it needs to be.
Okay, so we're giving those data packages a few extra chances to deliver themselves before we have to send them to the dead letter queue.
Precisely.
Speaking of which, are there any specific configuration tips for that safety net?
The DLQ configuration is usually pretty straightforward. The main thing is to monitor it. A dead letter queue that keeps growing signals that something needs your attention. Maybe a persistent issue with your API, or maybe a schema mismatch that needs fixing. Okay, so a healthy DLQ should be pretty quiet.
Exactly.
Now let's shift gears a bit.
Okay.
Talk about the S3 Sink connector. What configuration choices should our listeners be thinking about there?
One of the biggest decisions is picking the right data format. The connector supports a lot of different formats, but the best choice really depends on how you plan to use the data down the line. If you'll be doing analysis in a tool that likes structured data, Parquet is often a great option. It's columnar, which is efficient for querying, and it offers really good compression.
So it's about picking the right container for your data, kind of based on how you're going to unpack and use it later.
Precisely.
What if I need my data to be more human readable, though? Or I'm working with systems that mostly use JSON.
Well, then JSON is a perfectly valid choice. Or if you need something that's got a good balance between compactness, performance, and schema evolution capabilities, Avro is worth looking into.
So many options. It's all about picking the right tool for the job.
Right.
We also talked about partitioning as a way to organize all that data within S3. Any recommendations for how to come up with a good partitioning strategy?
Absolutely. If you're dealing with data from multiple Kafka topics, partitioning by topic is a good place to start, but you can definitely get more granular. Time-based partitioning, creating folders for like days or weeks or months can be super helpful if you're often analyzing data for specific time periods.
It's like a built-in time machine for your data.
Yeah, exactly.
What about those scenarios where I need to query the data based on a specific field, like a customer ID or product category, something like that?
Then partitioning by that specific field can really speed things up. It's like having a built-in index for your S3 data. Remember, those decisions about data format and partitioning, they might seem small, but they can have a huge impact on how well your data pipeline performs in the long run.
These are some incredibly valuable insights. So whether it's fine-tuning those batch and retry settings for HTTP or carefully picking the right data format and that partitioning strategy for S3, those small choices can really make a big difference.
They really can. Now let's zoom out a bit. Think big picture. Why should our listener be excited about these Kafka Sink connectors? What kind of cool things can they do with them?
It's about giving you, the listener, the power to build some really robust, versatile data pipelines that can handle all kinds of different use cases. Whether it's triggering those instant actions, like fraud detection, or unlocking insights from those massive data sets in S3, these connectors are the key.
They become those master architects of data flow, seamlessly connecting Kafka to everything else in your data world. Imagine combining real-time behavioral data with historical purchase information to create a 360-degree view of your customer, or powering a recommendation engine that responds to a user's actions in real time. So many possibilities.
It's like giving your data superpowers, the ability to move around freely, transform, and deliver value.
Exactly. And the great thing is, these connectors are designed to be flexible and scalable. Whether you're a tiny startup or a huge company, they can grow with you, handling those ever-increasing volumes of data.
So for our listener who's been soaking all of this up, what's next? What's the next step? Where can they go to start putting these ideas into practice?
The insights we've talked about today are a great foundation. Dive into that official Kafka documentation. Look for all those tutorials and examples online, and don't underestimate the power of the Kafka community.
That's right. The Kafka community is super helpful and very welcoming. You can connect with other folks in forums, meetups, online groups, all sorts of places. Ask questions, share your experiences, learn from each other.
Before we wrap things up completely, I want to leave you with a final thought. What other integrations might be possible with Kafka? We've really only scratched the surface of what this platform can do.
Think beyond what we talked about today. What other systems or services could benefit from real-time data or that seamless data archiving? The possibilities are pretty amazing. So go forth, explore, experiment, and unlock that full potential of Kafka. Your data is waiting.
And with that, my friends, we come to the end of our deep dive into Kafka Sink Connectors.
We hope you've enjoyed this journey and learned some valuable insights about the world of data pipelines. Until next time, happy data wrangling.